Okay, so ladies and gentlemen, you are welcome. So we are going to look at some question paper from POST-UTME 2018, and I hope you are going to enjoy the class. So the questions that we are going to look at is, let me share the question paper so that at least you will see the question and then we'll see how to solve them one after the other. So you see from question 1 here, the question 1 says, how many moles of oxygen atoms are present in 4.0 gram of the gas? So the question says how many moles of oxygen atoms are present in 4.0 gram of gas. So you see question 42, that is how many moles of air. So the mass of oxygen, the first thing to do is to say the mass of oxygen is equal to 4.0 gram. And then after this, after knowing the mass of oxygen, and then the next thing we said oxygen gas. So we know that oxygen is always exists as diatomic, and the mass of oxygen, as we can see from the question, is 16. So, and of course, oxygen cannot exist as monoatomic gas. So therefore, it is diatomic. So we are now going to say 2 times 16, and this will give us 32 gram per mole. And as we can see from the option A, we have 0.25, option B we have 0.50, and then option C we have 1.00, and then option D we have 4.00. So I think if you really saw the question from here, we can now say that we are now going to solve the question. So we know that mole is mass all over, molar mass. Although there are so many formula that we can use in calculating mole, we know that there is a formula that says mole N is equal to CV. This one is also used in calculating mole. So N is standing for mole, and then C is concentration, and V is volume. So in case if you are given concentration and volume and you are asked to calculate mole, then you can use this. There is also another formula that you can use in calculating mole. There's a formula that says mole N is equal to number of particles. We have a formula that says mole is equal to the number of particles, divided by Avogadro's number, which is 6.02 times 10 raised to the power of 23. So this one is also another formula that you can use to calculate mole. And then the next one after this, we also have a formula that can use to calculate mole. There is a formula that says mole is equal to volume all over 22.4 dm cube. So this one is also a formula that you can use to calculate mole. So I think from here, since we are given mass already and we have the molar mass, I think this is the best formula that is going to use here. So therefore, we are now going to say mole is equal to the mass is 4.0, and then the molar mass is equals to 32. So without wasting much of our time, we are now going to take our calculator to get the mole, which is from here. We can now see that we have 4 divided by 32. So 4 divided by 32, what are we going to have? Please write it on the comment section. You have 30 seconds. Write it on the comment section of the video. 4 divided by 32, what do we have? What do we have? So from here, my answer is 0.125. So I have 0.125 mole. So this is the answer. So let's go back to the question and see if we have that option. So I think, ladies and gentlemen, as you can see from the options, we don't have, we see option A is 0.25, option B is 0.5, option C is 1.0, and then option 4 is 0. So I think, ladies and gentlemen, we can see clearly there is no that answer, but this is how to solve it. So you can, in answering question or in answering POST-UTME, you may actually come across some questions that you might find their answers, and at the end it is not there in the option. So in most cases that would be a bonus. Do you understand? So now the next thing, let's look at the next question. Let's look at the next question. So for the next question, which is question 43 here, is that you see in the periodic table, the entire element within the same group has the same A, atomic number, B, number of electrons in the nucleus of the atoms, and then C, number of electrons available for bonding, and then D, isotope. So let me ask you, please, what do you think could be the base? What will be the answer to this? So the answer to this, actually, ladies and gentlemen, when we said elements are in the same group in periodic table, let me just give example. Let's say we have elements like, let's say, sodium. Sodium is an element with atomic number 11, and then hydrogen is also another element that have atomic number 1, and then we have potassium, and it has atomic number 19. So if you check the electronic configuration of sodium, we have 2, 8, 1. For hydrogen, we have 1. For potassium, we have 2, 8, 8, 1. So this is actually the electronic configuration of these 3 elements. So if you can see clearly from here, sodium has 1 electrons available for bonding. Hydrogen also 1 electrons for bonding, and then potassium also 1/2 electrons. It also have 1 electron for bonding. So this is to tell you that elements in the same group have the same number of shell. Elements in the same group have the same number of electrons on their outermost shell, that is valence shell. And this is to tell you that sodium has 1 electrons on the outermost shell, hydrogen also has 1 electrons on the outermost shell, and then potassium also has 1 electrons on the outermost shells. And this is to tell you that all the elements are having the same number of electrons on their outermost shell, and the number of electrons are the electrons that are available for bonding for each of these atoms. So generally, elements in the same group, it means that they have the same number of electrons on the outermost shell, and that is why those electrons that are present on the outermost shells, it means that they are electrons that are available for bonding. So I think, ladies and gentlemen, as you can see from the question, which one is the correct answer? So I think if you can look at the question, let's lead to the question. In the periodic table, the entire element with the same group have the same or has the same number of atomic number, the number of electrons in the nucleus of their atoms, then C, the number of electrons available for bonding, and then the option D, the number of isotopes. So I think, as you can see clearly from the questions, ladies and gentlemen, okay, good morning, Adam Jobrin. So you can see that the answer is option C. The answer is option C. And apart from group, we also have shell. So we also have, apart from the group of the element, we have also period. So how do we know that elements are in the same period? So the element in the same period have the same number of shell. Let's see here, you have sodium. So sodium has 11, magnesium has 12 atomic number, and then aluminum has 13 atomic number. So if you are actually to arrange the electronic configuration of this element, we are now going to have H21, and then here we have 2, 8, 2, and here is 2, 8, 3. So from here, Adam Jibril, which group is the chlorine, is the sodium atoms belong to? What is the group of these 3 elements? From this electronic configuration, which group is sodium belong to? Which group is sodium belong to? Write it on the comment box. Which group is sodium belong to? And which group magnesium belong to? And then the aluminum. So I think from this explanation, you can understand that elements in the same group have the same number of electrons on their outermost shell. So this to tell you that sodium is in group 1 and then magnesium is in group 2, because the total number of electrons on the outermost shell is what will indicate the group to which the element belong to. And then we have aluminum. So aluminum is in group 3 in the periodic table. So then the number of shells is what actually determine the period to which the element belong to. So this is our first shell, this is our second shell, and this is the third shell. So it means that sodium is in period 3. Also in the case of magnesium, it has 2H2. It means that it is also in period 3. And then also aluminum is in period 3 because it also has 3 shells. So the number of shells is what determines the group to which the element belongs in the periodic table. I hope you are following. So now let's look at the next question. We are moving to the next question. So the next question says, how many atoms are there in 0.3 mole of an element, and the Avogadro's number is 6.0 times 10 raised to the power of 23. So option A is 2.0 times 10 raised to the power of 24. And then option B is 1.8 times 10 raised to the power of 24. Option C is 1.8 times 10 raised to the power of 23. And then option D is 3.0 times 10 raised to the power of 22. So I think, ladies and gentlemen, I gave you a formula here. If you can see clearly, I told you that we have, look at the question very well. So we have, I already gave you the formula, because there is a formula that says mole is equal to the number of particles. So this number use this formula. Okay, the number of the atoms divided by 6.0 times 10 raised to the power of 23. The reason why I'm using 6.0, not 6.02, is because if you can check from the question, what they gave is 6.0, not 6.02. So therefore, we already have the mole as 0.3. Then it's now equals to the number of atoms divided by 6.02. So the 6.0 times 10 raised to the power of 23. So then the next thing now that we are going to do, we are now going to multiply this 6.02 times 10 raised to the power of 03, because here what we are going to do is cross multiplication. So therefore, we now have the number of atoms. So when you now set the number of atoms times 1, it will give us the same number of atoms. And then now we are going to multiply 0.3 times 6 times 6.0. So we now have 0.3 times 6.0. So this will give us, at the end, when we multiply this and this, is going to give us 1.8 times 10 raised to the power of 22 atoms. So these are the number of atoms that we have here. So therefore, the answer is 1.8 times 10 to the power of 23. So let me see if we have this option in the question. So you see we have 1.8 times 10 raised to the power of 24, and we have 1 point. Okay, I forgot. Here is supposed to be power 23. So therefore, the answer is, as we can see, the answer is option C. So now let's look at the question 45. Milk exposed to air for a few days tests. So when you expose milk to air for a few days, so it tested sour due to the presence of. So now the question is, which of the acids make the milk to test sour? So remember, ladies and gentlemen, in chemistry, we have what you call an acid. And what is an acid, ladies and gentlemen? An acid is a substance that ionize in water to produce hydrogen ion in a solution, or hydroxonium ion. So an acid is a substance that when ionized in water, it will produce hydrogen ion in a solution. So when you have an acid is a substance which when actually ionized in water, it produces hydrogen ion or hydroxonium ion. So an acid is a substance which when ionized in water, it will. So let us see the other options. So we have ethanoic acid, we have citric acid, then we have the other one, we have lactic acid and tartaric acid. So let me hear from you. Which one do you think is the correct answer? Which one do you think is the correct answer? So before you go that, we have types of an acid. We have types of acids based on their source. We have types of acid based on their source. We have number one, we have organic acids. So what is organic acid? Organic acid is an acid that usually found in, or that usually found from living organisms. So it's an acid from living objects. And then we have number two, we have inorganic acids. So examples of inorganic acid, we have something like HCl, H2SO4, and then we have HNO3. All these are examples of inorganic acids. And examples of organic acid, we have something like lactic acid, we have citric acids, we have, apart from the citric acids, we have ethanoic acid. All are examples of acid. So the citric acid is found in orange, while the lactic acid is found in the milk. So therefore, what makes the milk to have a sour taste is lactic acid. So the answer is option C. The answer is option C. So now let's look at another question, which is question 46. A substance which produces the hydroxonium ion as the only positive ion when dissolved in water is. So you see, I just defined an acid, that an acid is a substance when ionized in water will produce hydrogen ion or hydroxonium ion as the only positive charge. So we see, as I said, we have different types of acid. We have organic acid and we have inorganic acid. So the answer to this is an acid. So an acid is a substance that when ionized in water, it will produce hydrogen ion. So therefore, the correct answer is, if we can check from the question, the answer is an acid, which is option A. So then the next thing, petrol can be obtained from a fuel by A, hydrolysis, B, hydrogenation, dehydration, and then we have cracking. So which of the following is used in obtaining a petrol from fuel? So actually, a fuel oil is a crude oil where we obtain petrol. And the process in which a petrol is obtained, from uh, is obtained from fuel oil is fractional distillation. So a fractional distillation is one of the separation techniques that use in separating a complex mixture based on their differences in boiling points. So ladies and gentlemen, we generally, like for example in fuel oil, is a crude oil that composed or that is made up of so many products. From fuel oil, you can get crude, you can get petrol, you can get kerosene, you can get diesel, you can get bitumen. There are many of them. And the process that is used in removing all these components from the fuel oil or from the crude oil is called fractional distillation. And we have two other methods that can use to further process your petrol from the crude oil. And those process is called, number one, we have refining, and this refining and also cracking. So these are the two other methods that after you obtain your petrol from the crude oil, you have to further process it. And that processing includes the refining and then the cracking. So I think if you can check the option, there is no fractional distillation and there is no refining, so you can choose cracking because the fractional distillation is not there. So the answer here is going to be cracking. So you see option D will be the best answer here. So now the next thing is, we are now going to look at another question. Which of the following is not a true of metals? Which of the following is not true of metals? So first, ladies and gentlemen, which of the following is not true for metals? Metals, they are good conductors of heat and electricity, is correct. They are malleable and ductile. Also, this one is correct. Yes, Fatima Abdullah, good morning and you are welcome. So I want to, so that we should be answering this question together, although I think that there is no much people here because there is late notification for the class. So I feel that, let me just ask you, the two of you that are now joining this, please can you continue with this method so that we'll be taking Can we continue with this method so that we'll be taking past question paper and then we'll be answering them? Please, are you okay with it? I want you to write. Are you okay with this pattern? We'll be taking past question paper and then we will be solving them together. So what do you say about this? So let's answer. So which of the following is true about a metals? They are good conductors of heat and electricity. And then B, they are ductile and malleable. C, their oxide are basic. And then D, they are used as insulator. So I think the correct answer here, without wasting much of our time, we know that metals are good conductor of heat and electricity. And you are malleable and ductile, meaning that you can draw them into a thin wire and you can change them into differential. That is the meaning of malleability and ductility of the metal. And we have oxide. What is oxide? An oxide is when you have an element, when you have two elements. And the element, one of the elements must be oxygen. So an oxide is when you have two elements. Ladies and gentlemen, let me write it. An oxide is when you have oxides that contain only two elements, and one of the elements must be oxygen. Must be oxygen. So it must be oxygen and any other element. That is what you call oxide. So it's an oxide of two elements, and one of the element must be oxygen, and the other one can be any other. So, and we have types of oxide. We have types of oxide. We have one, acidic oxide. We have acidic oxides. And then number two, we have basic oxides. And then number three, we have amphoteric oxides. We have amphoteric oxides. And then number four, we have neutral oxides. Neutral oxides. So what is acidic oxide? Acidic oxide is the oxide of metal. Acidic oxide, it is oxide of metal, while acidic oxide is an oxide of non-metal. Acidic oxide is an oxide of non-metal, while basic oxide is an oxide of metal. Amphoteric oxide is an oxide of both metal and non-metal. And examples of this acidic oxides, we can have NO2. Basic oxide, it can be sodium oxide, CO2. Then another example of basic oxide, it can be calcium oxide. And then amphoteric oxide, we can have zinc oxide is an example of amphoteric oxide. We can have aluminum oxide is also another example of amphoteric oxide. So amphoteric oxide is an oxide of both metal and non-metal, while basic oxide is an oxide of metal. Acidic oxide is an oxide of non-metal, while neutral oxide is an oxide of neither metal or non-metal. So these are the types of oxide. So therefore, I think if you can also look at option C is also correct. Option C is also correct. So the truth is that the answer to this question is that the metals cannot be used as an insulator. So therefore, option D is the answer, because the question is saying that which of the following is not true of metals. So metals cannot be used as insulator. So the answer is, as we can see, the answer is D. So the next question that we are going to look at is question 49. Which of the following is not a property of chlorine? Chlorine is a greenish and yellow, has a choking smell. C, it bleaches litmus paper. It is a liquid at room temperature. It has a higher density than air. Of course, one, chlorine is a, let me clean here. Chlorine is a greenish yellow. It is a greenish yellow. Chlorine is a greenish yellow gas at room temperature. Get it? It is a greenish yellow gas at room temperature, and it has a choking smell. It also bleaches litmus paper, but it is not a liquid at room temperature. And the density of chlorine is higher than air by 2.5 times. It is higher denser than air by 2.5 times. So therefore, the answer to this is option C. So let's look at actually some of the properties of chlorine. So first, chlorine is a non-metal. Chlorine is an element with atomic number 17, so it has 287, meaning that it is a non-metal, so it can accept an electron. So that is what makes it to be a strong oxidizing agent. It is a strong oxidizing agent. So this is one of the properties of chlorine. So it is a strong oxidizing agent, and it is gas. It is gaseous at room temperature. So chlorine is gas at room temperature. So one, chlorine is a strong oxidizing agent, and two, it is gaseous at room temperature. And then chlorine, it is denser. That is, it has higher density than air. It has higher density. It has higher density than air by 2.5 times. It is higher denser than air by 2.5 times. And then the next one, it is poorly soluble in water. Chlorine, it is poorly soluble in water. Rather, it is more soluble, or it is higher soluble in inorganic solvent. It is higher soluble in inorganic organic solvent, not inorganic. It is higher soluble in organic solvent like ether, chloroform, and so many others. So these are actually some of the properties, and it is also used in the production of PVC. PVC, that is polyvinyl chloride. So this is actually some of the properties associated with These are some of the properties associated with the chlorine. So I think since from here we say that it is gaseous at room temperature, and one of the options says it is. Let me show you the option again. The option says it is soluble. It is a liquid at room temperature. So this is not correct. So which of the following is not a property of chlorine? So option C is not a property of chlorine, because chlorine, it is gaseous, or it is gas at room temperature. So then the next one is question 50. So the question 50 says, as we can see, if calcium has atomic number 20 and a mass number of 40, then the constituent of the atom is. So let's say this is a chlorine. So let's say this is calcium, and the mass of the calcium here is 40, and then the atomic number is 20. So the question is asking about the constituents. What are the constituents of chlorine? So I think it's simple. Sorry, the constituent of calcium. So of course this is atomic number and this is the mass number. And if you could remember, the atomic number and the mass number of an element are the same. So therefore, the atomic number and the protons number of an element are the same. So if atomic number is 20, it means proton is 20. And then by looking at this element, it is neutral because there is no positive charge here and no negative charge. So it means that the number of protons and electrons are equal. So if protons and electrons are equal, it means that the element is electrically neutral. So since calcium is neutral, so it means that the proton is 20 and the electron is 20. Then what about the neutron? So to get the neutrons, we know that the mass number, we have a formula which says the mass number is equal to proton plus neutron. So therefore the mass number here is 40, then is equal to proton is 20 plus neutron. So we now have 40 minus 20, we have n. So this minus this, we have 20. Without going further, B is the answer. B is the answer. So this is actually the end of the chemistry. This is the end of the chemistry. So this is the end of the chemistry, and as we can see, ladies and gentlemen, the proton is 20, electron is 20, and then neutrons we calculated as 20. So I think we are going to stop here, and I hope you enjoy the video. So please, I think we'll keep using this method if you felt that you are really interested to this kind of videos that we are going to be doing. So I hope you will really enjoy our classes. So thank you very much, and see you next. Bye bye.